Alright, so in this video, we're going to be finding the antiderivative of x squared plus 1 raised to the third power times 2x. So, what is this going to be equal to? So in order to find the antiderivative, I'm going to be using U-Substitution. And when I use U-Substitution, I need to set something equal to U. That's my first step. What is that going to be in this case? Is it going to be 2x or is it going to be x squared plus 1? Well, as I mentioned in a previous video, the U value is going to be typically the value that's raised to the power of something, or that's going to be under a radical. It's going to be essentially something that's inside something else. So here, x squared plus 1 is raised to the third power, so we can safely choose x squared plus 1 as our option. So x squared plus 1 is going to be equal to U. And this is our best choice, essentially. So now we want to find du, and this is going to be equal to the derivative of this, which is 2x dx. And again, notice that this is one of the easier questions. I will be doing harder questions in other videos, but just for now, I'm trying to get the idea and the steps down. So now let's replace what we have. So it's going to find the antiderivative. We can replace this x squared plus 1 with u, as I have here. So I'm just going to write that as u raised to the third power. And then I can replace this 2x dx with du, because that's what it's equal to, right? So this is just going to be equal to, do that in green, du. So we have everything in terms of u, and we can evaluate now. So we can use the reverse power rule, and this is just going to be u raised to 3 plus 1 over 3 plus 1. So this is going to be equal to u raised to the fourth power over 4. And then we can replace this u with x squared plus 1. So this is going to be x squared plus 1 raised to the fourth power. Raised to the fourth power over 4. And then always remember to add that constant of integration. We could maybe simplify this, but it's not necessary. We could maybe expand it or something like that, but that's not necessary. This is essentially what we get as our answer. And so that is our antiderivative. So I hope you found this video helpful.